Welcome back to our YouTube channel BST Lectures. Today our new playlist is Automata Theory and Formal Languages. It is one of the most important and useful computer science topic. Let us go to the topics. Topics to be covered in this lecture is what is an automata, types of automata, what is finite automata, what is push down automata, a Turing machine and the power of automata. Okay, now let us see first what is meant by an automata. Automata, automatic, auto regenerate, auto generate. These are the few words which comes into the mind when we listen auto. Auto means automatic, means self-generating, right? Let us know what is meant by automata. Automata theory is a branch of theory of computation. What is meant by the theory of computation? Let us know what is the meaning of theory of computation. Theory of computation is nothing but designing of computers. I mean designing of compiler designs. In this theory of computation, we will learn how to design the compiler designs. And this is a branch of theory of computation. Next, it deals with studying abstract machines and their capabilities for computation. An abstract machine is called the automata. It includes the designing of automata, which are mathematical models that can perform computations on strings of symbols according to a set of rules. This automata is a mathematical model which contains some set of rules to produce an output in the form of a string. Generally in the form of a string, and we might have several other forms. It includes analysis and design of computation systems, formal languages, automata theory, and complexity theory. Types of automata. We have learned what is meant by automata and from where the automata has been came. It came from the theory of computation. Now let us learn the types of automata. Automata is of the three types: finite, push down, and a Turing machine. Turing machine has the high computational power compared to these two. Let us learn what is meant by finite automata. Automata types. Finite automata. Finite automata is the simplest machine to recognize patterns. For every machine, suppose let us take a washing machine which contains some particular pattern or some particular design in it in order to wash the clothes. In the same way, the finite automata contains a language or a grammar in which in order to compute the automata. For example, the language used in this finite automata is regular language. The language which used in the finite automata is regular language. To be noted, it is very important. And the regular language, it has the regular grammar. For suppose, let me explain the simple words. For example, for suppose we are having English alphabets. English alphabets are used and combined to get the letters. Letters are combined to get the words, and words combine the sentence, and sentence together form a grammar. In the similar way, the language which we use in this automata is the regular language, and the grammar which we follow is the regular grammar. Alright, next point. The finite automata is an abstract machine that has 5 elements or tuples. This finite automata can be represented using 5 tuple notation. This is the tuple notation, and we can study about this finite automata into the deeper in the next lectures with the example diagrams, state diagrams, transition tables, etc. For now, let us just see the notations and what does they represent. Q, this symbol is summation in the mathematics, and for now let's call it as sigma, and this is the input symbol. Next, this is delta or transition function. Q naught and F. Q is represented with the set of states. For suppose we are having 5 states in the automaton, and the 5 states are represented with the Q. Set of the states is represented by the Q. Next, sigma. Sigma is the input alphabet, or you can also call as input tape, and delta is the transition function, and we learn about this transition function in the further lectures. It is very important in any type of the automata. Next, Q naught. Q naught is the initial or the starting stage where the input gets started in the automaton. Next, F is the final state where the input must end at the final state to get the correct output string. Next, this is the picture of the automaton. Now we have learned about the finite automaton. It is the simplest machine to recognize the patterns, which uses the regular language and contains the 5-tuple notation. This what we have learned in the finite automata. Okay, for suppose we have to perform 2-cube operation. 2-cube operation can be performed as 2 into 2 into 2. Right? 2 into 2 into 2. First we have to perform 2 into 2 is equal to 4, and then 4 into 2 is equal to 8. So before performing 2 into 2, 4 into 2, that is, the 4 value must be stored in some area. That area is not present in the finite automata. That is, the memory is not present in the finite automaton, right? We can perform only 2 into 2 is equal to 4 in the finite automata, but not 4 into 2, 8. 2 cube cannot be performed in the finite automata. Okay, what is the alternate for this? What is another type of automata that we can perform? So let's get into the next automata, push down automata. Push down automata contains an input tape in the automaton and the stack element. We know, right? Stack stores the elements which contains the top of the stack. So here stack stores the element which is the memory element of this push down automata. In finite automata, we are having regular language. In the same way, in the push down automata, we are having context free language, and the grammar used in this push down automata is context free grammar. Okay, now let's see push down automata. Push down automata is a finite automata with extra memory called stack. To be noted point is extra memory called stack, which helps push down automata to recognize context-free languages. Yeah, we have learned 5-tuple notation in the finite automata. Likewise, we are having 7-tuple notation in push down automata. So let's see the 7-tuple notation here, and I'm just explaining it in a briefer way, and the next further videos you will get deep into this push down automata. Q represents the set of states as usual. Input tape, set of inputs, sigma. Next, it is the Greek letter which represents the set of stack symbols. Q naught initial state, Z initial stack symbol. We can represent it with the Z or a dollar symbol also. F set of final states, and the last but not the least, which is very important, transition function. In the finite automata, we are having only 5 tuple notations, whereas in the pushdown, we are having 7 tuple notations. Why? Because we are having the stack. So for set of stack symbols, and for initial stack symbol, we are using 2 extra tuple notations. Now let us get into completed 2 types of machines: finite automaton, push down automaton, and the third type is Turing machines. And we have seen that the limitation of push down automata is no memory, and the the finite automata has no memory to store, and the limitation in the finite automata is the advantage of the push down automata, which has a stack memory to store the elements. And now we are going with the Turing machine. In Turing machine, we are having infinite number of tape symbols. I mean input tape symbols. So this is one of the biggest advantage in the Turing machine. We can take an infinite number of input symbols in it. What is a Turing machine? It's like a hypothetical computer with a simple structure, but it's very powerful enough to represent any algorithm or computational process. Here is the triple notation of the Turing machine. Here, if we observe, this is the input tape which contains n number of input symbols, but we can have in between the blank spaces. In the B represents the blank spaces. Here we are having sub 7 triple notation as the previous one. The x sorry 8, and the extra one is the blank space B. About this we can learn further in the next lectures in a detailed view. As we talk about power of automatons, finite automata has less power compared to the Turing machines, because Turing machines has memory to store, infinite input tape, and many other advantages compared to the finite automata. So finite automaton less than push-down automata less than Turing machines. The lesser power gradually increases in this way. Next, we are having these are the advantages and disadvantages of the automatons. Please go through this. And these are the real-time examples of the automaton. Vending machines, ATMs, automatic doors, female email filters, etc. These are the real-time examples of the automaton we use. For example, ATM machines. When we insert the card and press the amount what we needed, and it gives us the amount. This is the one of the real-time example. We use a automata. Please do like, share and subscribe our channel BST Lectures, and comment your valuable comments to us, which are very required to improve ourselves, and comment your topic which I want to teach in the next lecture, and follow for more topics. I will teach the ATFL playlist, full theory of computation. Thank you.